Hey everyone, in this lesson we're going to be talking about the quadratic formula. Specifically, we're going to be talking about, okay, how can we come up with a formula that would allow us to solve any quadratic equation, no matter how complicated it is, by plugging in certain values into a formula. So we're going to be starting off with basically the function for a quadratic in standard form. So if you remember, for a function in standard form, we basically have three terms. Uh, it's ax squared. I'm going to put here plus bx, and I'm going to add plus c. Let me make that a different color. Let's go with, sure, green. So this is a standard form for a quadratic function, a quadratic equation, basically. So this is your standard form for a quadratic function. And the idea is, if you have it in standard form, is there a way for me to be able to solve any quadratic function by just using the coefficients a, b, and c? And the answer is yes, there is. But for now, we're going to try to figure out how we can actually do that. So let's start off with the fact that we already know how to find the solutions by completing the square of any function in standard form. So if you remember, for completing the square, if we have any function, or I shouldn't say any function, any quadratic function in standard form, set equal to 0, so it looks something like this. If you wanted to solve this by using the method of completing the square, we could actually do that to get the x by itself. And what that method says is basically if we just draw the wall, right, and then subtract c on both sides, so subtract c, we're basically trying to get all the x's on one side, or all the variables on one side, and then all the numbers on the other side. So on the left-hand side, I'm going to be left with ax squared plus bx. On the right-hand side, I'm going to be setting that equal to negative c. So far, I haven't done anything fancy. I just got all the variables on one side, all the numbers without variables on the other side, which is basically the first thing when we're doing completing the square. Now, when you do completing the square, right, most of the time what they tell you to do is that you have to have the a, or the number in front of the variable x squared equal to 1. So let's do that. First thing we need to do to use completing the square, we need to make sure that this value right here is equal to 1. Right now it is not equal to 1, but I can force it equal to 1 by just dividing this by the coefficient a. If I do a divided by a, then I get a 1. So I can actually use completing the square. If I do it to one of them, though, I have to do it to all of them because it is an equation. So we have to keep the equation balanced. So on the left-hand side, I have x squared, because this a divided by a turned into a 1. The middle term becomes b divided by a, so I'm going to put plus b over a. And then that had an x, right? So I'm going to put x in front of it. On the right-hand side, I just have the negative c over a. So I'm just going to copy that, negative c divided by a. So it looks complicated, and it will probably look more complicated as we go through, but it's just the same steps that we did for when we completed the square. So now we have the a term equal to 1, right? In front of this x squared, there's a 1. The middle term is b over a, and then the c over a negative, it moved to the other side. Now we can complete the square. So if you remember the steps to completing the square, so we draw a box, right? Perfect square. On the top left-hand side, I'm going to have the x squared. Here I'm going to have the middle term divided by 2. So now think about it. If I have b over a, which is the middle term, and I want to divide that by 2, basically dividing by 2 is the same thing as multiplying by 1 over 2, right? So when I multiply this by 1 over 2, I'm dividing by 2. Basically, it's the same thing as if you had this from way back in 7th grade, and you divided that by 2. This is the same thing as dividing by 2 over 1, so you would do the keep, change, flip, right? So b over a multiplied by 1 over 2. It's the same thing as dividing by 2. So anyways, when we multiply this times this, we get half of that, right? Which in this case, half of that would give you this middle term as b divided by 2a. So I'm going to go ahead and write that in. B divided by 2a here, and b divided by 2a there. Now, when I complete the square, so all I did was take this term and divide it by 2, and then I get this and this. So when I complete my perfect square, all I have to do with this box is multiply these two together, right? So I would actually have to multiply the b over 2a times the b over 2a and put it here. And it looks kind of funky, but at the end, you're going to get b squared divided by 4a squared. So b squared divided by 4a squared. Let me erase this line. Make it nicer, or make it bigger, I should say. So b squared divided by 4a squared. Okay, so again, we're just trying to figure out what we're going to add to both sides. Now that we figured that out, okay, let's do that to this side. So we're going to add b squared divided by 4a squared to this side. We're going to add the same thing to this side, b squared divided by 4a squared to this side. So the whole idea is we're trying to get the x by itself. Okay? Now that we have this perfect square, we know that on the outside of that square, I can have x, I can have b over 2a, and I have the same exact thing on the top column, b over 2a and x, which means that this is basically a perfect square. This perfect square becomes x plus b over 2a, all squared, right? Times itself on the outside of the box, which is all squared. And then on the right-hand side, I get this weird two fractions, negative c over a plus b squared divided by 4a squared. I cannot add these two yet. So right now I want to make sure that these two denominators are the same. So if you think about it, what can you multiply top and bottom of this to make sure the denominators are the same? The answer for that would be if I multiply top and bottom by 4a to this side and to this side, I will get the denominators on the bottom to be the same. And therefore, I could actually add or subtract these two fractions. So let's go ahead and do that. So on top of this fraction, I'm going to get negative 4ac. That came from the 4a times the negative c. On the top side, I have b squared. And then all over, because that whole thing just became that same denominator, right? So everything was over now for a squared. So I have my, basically my method for completing the square to get the x by itself. And I'm almost done. I get something that looks really funky, but in the end, we're going to try to make it look a little nicer. Okay, so let's start with this. So let me switch the order by the commutative property of the b squared and the negative 4ac. I'm just going to move them. I'm going to switch the order. I'm going to just swap them. And then on the left-hand side, I'm just going to leave everything alone for right now. So it's x plus b divided by 2a. All that is going to be squared. And then set that equal to this, which is b squared minus 4ac. I just swapped them. So it's the same exact thing. And then I put it all over for a squared. All right, now I want to solve for x, right? So when I want to solve for x, I want to take the square root of both sides. And then whenever you take the square root of something, you always have a plus and a minus in front of it. So don't forget about that part. So on the left-hand side, I'm left with x plus b divided by 2a. And the square is gone now. On the right-hand side, I'm left with plus or minus the square root of all that junk, which is b squared on top, minus 4ac, and then all divided by 4a squared. Okay, getting there. We almost have the x by itself. Remember when you take the square root of something, you can split that square root into the top and the bottom. So I'm going to go ahead and do that. I'm not going to mess with the left-hand side yet. So x plus b over 2a is equal to, I still have a plus or minus here. And then I'm going to take the square root and move it to the top. And then I'm also going to have another square root on the bottom. So I'm going to split that into the fraction, right? The top is going to be the same thing, b squared minus 4ac. The bottom is going to be 4a squared. Why did I do that? Because I could actually take the square root of the bottom. I don't know what the square root of b squared minus 4ac is, but I can simplify the bottom a little bit more. So I'm going to go ahead and do that. The square root of 4 is 2, and the square root of a squared is just a. So if I simplify the right-hand side, I'm left with x plus b over 2a on the left-hand side. The right-hand side, I only mess with the bottom, the denominator, which is going to be, the top stayed the same. So the square root of b squared minus 4ac. The bottom is going to become now the square root of 4, which is 2, and the square root of a squared, which is just a. Okay, now all I have to do is get the x by itself. So I'm going to go ahead and draw the wall, right? So make a line down the equal sign, draw that wall, and I'm going to add, or sorry, not add, subtract b over 2a to both sides, negative b over 2a. Because I want to basically get the x by itself, and I want this to cancel with that. And it does, right, on the left-hand side and the right-hand side. So I'm basically done. I just have to make this look a little nicer, and then I have a formula that I can use to solve any quadratic equation that I could possibly want. So now that I have the x by itself, I'm going to be writing this out. I'm going to write this first, the negative b over 2a. So negative b divided by 2a. And then I'm going to put plus or minus the square root of b squared minus, ooh, that looks funky. Let's make that be better. B squared minus 4ac, and then over 2a. If you notice, 2a and 2a happen to be the same exact denominator, right? So we could actually combine those two into one single denominator. So what we're left with is what is called the quadratic formula. The quadratic formula is x, any root, right, is equal to the negative b, or opposite b, plus or minus the square root of the value of b squared minus 4 times a times c, and then you're going to put it all over 2 times a. This is the quadratic formula. If you plug in the values of a, b, and c of any quadratic function in standard form, you will get the solution so long as you simplify it properly. So what this means is whenever you have a function in the form ax squared plus bx plus c, if you know what your terms a, b, and c are, so you have these three values, and you plug them into this formula, you will get your roots. And this is the magical quadratic formula.